Audio going? It's moving. We got audio. All right. Cool. Okay. So, like I said previously, the mole is a bridge between things we can measure, grams, and things we can't, atoms. And previously, we did the conversion between grams and moles. Now we're actually going to finally build the rest of the bridge and go from moles to atoms. So previously, we did little T-charts where we said so many moles, and then we brought down moles and converted to grams. Or we did a T-chart and we said we have so many grams, and we're going to convert from grams to moles, right? I also told you that that was last week, and then this is this week. Now we're here. So we're going to take this, and we're going to add a single more block. We're going to say, all right, now I can convert my moles to atoms. Actually, this goes down here. I can convert my moles to atoms or molecules. It's just one more block. And the block is Avogadro's number, which is 1 mole equals 6.02 times 10 to the 23rd atoms or molecules. So when you're converting from grams to atoms, you have to hit moles first. Mole is the bridge that gets us from where something we can measure, grams, to something we can't, atoms. So we go grams to moles to atoms. If you're with me so far, give me a thumbs up. We do a bunch of practice and keep that right up. Now the other way is if we're starting with atoms or molecules, then just like this, we're going to say I have so many atoms or molecules, and it's going to be 6.02 times 10 to the 23rd atoms or molecules, then to moles, which is 1 mole, and then to grams. By the way, this is where you respond. Where does a gram to mole conversion come from? Periodic table. So anytime you go from moles to grams, periodic table. Anytime you got to go from grams to moles, periodic table. That's today. And that's pretty much the end of molar mass. So we're just going to say, all right, if I want to know how many grams I have, if I have a number of atoms, I'm going to convert my atoms to moles and my moles to grams. And if I have grams and I want molecules, I'm going to go grams to moles, moles to molecules. So let's go do one together. How many atoms are in 3.52 moles of silver? This is a single block. Doesn't have grams. We're going from moles to atoms. So anytime we do a conversion to our T-chart, like so. And what goes down here in the lower left? Nothing. Because there are 3 things in each block. There's a number, a unit, and a label. The number in this case is 3.52. The unit in this case is moles, and the label in this case is silver. And we're always going to move down the unit and label to get it to cancel out. Whatever is here is always coming down here. So I'm going to move down my moles of silver. And to what am I converting?
Atoms.
Atoms. It used to be like moles to grams. No, now it's moles to atoms of silver. And Avogadro's number is, all right, 1 mole of silver atoms is 6.02 times 10 to the 23rd atoms of silver. So bang that. Ooh, bang that out. Do I need to turn the lights on? It would be brighter if I turn the lights on. Would that help, or would that hurt? Hurt? Okay. If you're squinting, I need you to move closer to the screen. That would be great. Squinting makes me nervous because I was your age and I was like, I got better glasses every few years. I'm like, oh my gosh, this is awesome. Look how much better I can see. Imagine what I could have accomplished if I could see better the whole time I was in high school. That's where you guys are. If you're squinting, get better glasses, please, or contacts or whatever you wear. So again, bang this out. On the white calculators, they actually have a ×10 of the button at the bottom, which I absolutely love. And it looks like nobody's using the yellow calculators, which is great. On your own calculators, it's probably either a Y to an X or an EE key, an exponential notation key. And if you're looking for a good Halloween gift from your parents, like, Mom, trick or treat, can you give me a numbers calculator? They're cheaper than TIs and they work a lot better and they're fully programmable and I can take it with me to college because it has lots of engineering stuff on here too. I promise not to jam a pen in the power connector. The guys who actually designed these, they actually emailed me back. I actually said, hey, could you make the power connector a little bit tougher because a kid could just jam a pen in there? Look what they did. A good picture, a good one. They emailed me back and said, we'll take that into account. Thank you. That's all for them. Harden the USB port. Or even better, make it wireless. Just stick it on a wireless charger. Dual ports. Okay, so when you multiply these things out, you should have got a number, a big number, because there's an exponent. Who can volunteer what they got?
2.119744 to the 24th power.
2.12 times 10 to the 24th, and the units are going to be whatever we're left with. Is that what you had?
Yeah.
Okay. And the units are going to be atoms of Ag. Atoms of silver. Right? Cool?
Is that right?
Yeah, looks good to me. This is basically 3.5 times 6, which is around 21. So it would be 21 times 10 to the 23rd, and then you move that mantissa 10 times smaller, the exponent becomes 10 times larger. Oh, by the way, this number is called the mantissa. I didn't name it. It just is that way. Mantissa. I don't know why it's called a mantissa. It just is. So in the when you're taking your test, it's going to say, enter the mantissa of the exponent. In other words, I don't want you to try to write all of table 1 over the autograder. Just write the mantissa, and if the mantissa is right, pretty good chance that the exponent's also right. Sometimes they'll even give you the exponent. Be like, the exponent's 10 to the 26th. You come up with the mantissa. Like, I got the same answer, 10 to the 26th. I probably got the right answer. I got 10 to the 22nd. I probably didn't do it right. That's what it's called. Mantissa, and of course, this is the exponent. All right, if you're with me so far, give me a thumbs up. If you have any questions, wave your hand around. All right, let's go back. Let's do another one. Let's go the other way. 0.0181 moles of copper. How many atoms is that? Actually, no, I think we're good here. Let's go back the other way. How many moles do you have in 2.43 times 10 to the 24th atoms of helium? So, okay, I think I can erase this. We're going to start like we always start. Nothing goes here. What goes up here? Yeah, atoms of helium. So 2.43 times 10 to the 24th. To the 24th. Atoms. Helium. Okay. And again, as always, this unit label is going to come down so we can cancel it out. So this is coming down atoms of helium. To what am I converting my atoms of helium?
Moles.
Moles. Mole helium. And now, since I know the pattern, Is it going to be 1 mole or 1 atom? Where's the 1 going to go?
Mole.
1 mole is 6.02 times 10 to the 23rd atoms of helium. Can you bang this out? So 2.43 times 10 to the 24th is slightly larger than 10 to the 23rd. So you would expect to have a number of moles that is slightly larger than 1. It looks a lot like 24 times 10 to the 23rd, 10 to the 23rd. So it looks like it's going to be in the neighborhood of 3. So hopefully you got something in the neighborhood of 3. If you use the white calculator, you did. If you used a TI calculator, did you get the correct answer?
I don't know what the correct answer.
What did you get?
I don't think I got the correct answer.
What was the exponent in your on your calculator?
47.
47. And that's because TI calculators are stupid. They require you to put things in parentheses if you do the times 10 to the whatever. If you use the white calculators, the times 10 to the is implied and it puts it into a parentheses automatically. But if you use the TI, you have to do this. You have to say 2.43 times 10 to the 24th, that's fine, divided by parentheses 6.02 times 10 to the 23rd. That will get you where you need to go. Because the TI doesn't realize that that's exponential notation. You can avoid this by saying 6.02 exponent 23, but your math teachers don't like you to do that. They don't like you to use the exponent key because I have no idea why. Jason.
I did the same thing on the numworks and I got 40.
40?
Yeah, 40.2654485.
It's because you did 24.3 to the 24th instead of 2.43 to the 24th.
Ooh, shady.
All done, Bo.
That'll do it. Thank you, bro.
Okay.
That's called teamwork. So yeah, something in the neighborhood of 4.0, right?
Yes.
About 4.0 moles of helium. And again, if you're using a numbers calculator, they're like, oh, you want to divide numbers with exponents. I gotcha. And it automatically makes it a fraction. The TIs don't do that, which is the single reason I've spent a bunch of time and money equipping the class with those calculators, because they do that one thing. I have tried for the last 20 years to get math teachers to allow you to use the exponent key, and they hate it still. They want you to go times 10 caret 23rd. So if you don't use a numbers calculator, just be real careful that you're doing the mental math to realize, oh, if I divide a 10 to the 24 by 10 to the 23rd, I should get a small number, not a massive number like 47. All right, if you're with me so far, give me a thumbs up. If any part of this needs to be repeated, wave your hand around. Okay, now we're going to do the two-stepper. Here we go. How many grams in 2.41 times 10 to the 24th atoms of helium? Now we're going to do the whole thing like we're going to do in the future with multiple steps. Our steps are going to stay this, but now they're going to be that. We're still not going to put anything in the lower left. And we're still going to put a number, unit, and label in the upper right. 2.41 times 10 to the 24th atoms of helium. And we're still going to move down the unit in the label because that needs to cancel out. Atoms of helium. And as great as it would be to convert from atoms to grams, that would be like jumping over the river. We can't do that, it's too far. So we have to build a bridge, and that bridge is the mole. So we're going to take our atoms of helium and we're going to convert to moles of helium, which we can do. We know that anything to atoms is going to be 1 mole, 6.02 times 10 to the 23rd. The current unit is moles of helium. Is that what we want? No. So we simply make another box. We simply bring down our unit and label. Again, just like what was here becomes here, what is here becomes here. I'm going to use different colors because I like using color pens. Moles of helium. So just like what was here goes down here, what is here goes down here. And now we're going to convert from our moles of helium to our grams of helium. And where does a mole-gram conversion come from? Periodic table. And the number, very clearly created by one of your classmates, says 4.00. So it says 1 mole of helium is 4.00 grams. Yay, we've got the unit we want. Now it just becomes math. 2.41 times 10 to the 24th multiplied by 4.00 divided by 6.02 times 10 to the 23rd. You guys know how to use fractions. So conceptually, 2.41 times 10 to the 24th is pretty close to times 10 to the 23rd. It looks a lot like 24. So it looks like there's about 4 moles. And if there's 4 moles and there's 4 grams per mole, maybe 16-ish? What number did you get for the number of grams?
16.012.
16.0 grams of helium. That's it. That's as complicated as it gets until January. In January, we'll start tacking on extra boxes. But until then, that's it. Grams, moles, atoms. Atoms, moles, grams. Questions? If you think you're ready to work on your own, give me a thumbs up. If you need me to repeat any of this, wave your hand around. All right, so use the remainder of time to work on your own. And I'm going to bring up a bunch of sample exercises. There we go. And back to that after I turn.